This is going to be a walkthrough of our practice problems that we did the other day, speed and velocity practice problems. And this shows you how to do everything step by step, just like I showed you in class. So for you to get credit on this, you're going to need to show all work. So let's walk through this again. Here we go. So the first problem says, calculate the speed of a dog running through a field if he is covering 23.7 meters in 54 seconds. So it's always a good idea to figure out what is given to us and what is needing to be found. So the unknown. So what do we solve for basically in this? So calculate the speed. It's underlined. They won't always be underlined, but this one is. So calculate the speed. And so that's what we're looking for. But what is given to us? It says 23.7 meters in 54 seconds. So what's given to us? Well, the distance is given to us. We can tell that by meters. We know that meters is a length and that's a distance. And also 54 seconds is a time. So both of these things were given to us. Now what we're solving for happens to be underlined, and we know that speed, the SI unit for speed, is meters per second. So we have to look at our formulas that we've learned, and we have two of these three things in a formula. So we distance, time, and we're looking for speed. So we can use the speed equation. So speed is a distance divided by a time. So once we get our formula written in there, we can just plug in the distance and the time. And we want to make sure we have units there. But once you divide this using your calculator, you'll find that it's 0.4444, a bunch of fours, but I have decided to round it to the hundredths place. So this is speed is 0.44 meters per second. Example number 2 says, if a cross-country runner covers a distance of 347 meters in 134 seconds, what is her speed? Again, this is exactly like the first problem, where we're given meters, a distance, and it even says distance of 347 meters. So we'll write that in the givens, as well as the 134 seconds, that's the time. So distance and time are given to us, and we are going to solve for speed. And it's underlined right there. So speed, again, is in meters per second. So this is exactly like the first one. So we're going to put our speed equation on there. So speed is equal to d over t, distance over time. We're going to plug those into our formula, 347 meters divided by 134 seconds. And we come up, rounded to the hundredths, at 2.59 meters per second. That's number 2. Number 3. Now this is a little bit more challenging just because it's telling us that we want it in meters per second. So again, we're looking for speed. But it says, what is the speed of a horse in meters per second that runs a distance of 1.2 miles in 2.4 minutes? So again, it's given to us, the distance at 1.2 miles is given to us, and the time at 2.4 minutes is given to us. We are again solving for speed. So speed in meters per second. And it tells us that in red, meters per second. Okay, we are not in meters per second. So we need to figure out how to get miles into meters. And so I'm going to do a little side box down here. And we're going to go to our SI measurement sheet and find the equivalent statement of miles to kilometers to get us from English units to metric units. And then we can get from kilometers to meters. So I'm going to use 1 mile is equal to 1.609 kilometers. So that will get us from miles to kilometers. And then we need to get from kilometers to meters. And we can use 1 kilometer equals 1,000 meters, because kilo means 1,000 times greater than whatever base unit we are. So a kilometer is 1,000 times bigger than a meter. So it would take 1,000 meters to get a kilometer. So let's put in our distance. And I've done all the math here right away, but I'll walk you through how to do this. So we started with 1.2 miles. And so my first, let's see if I can even write on this. I think I can. So my first, I'm going to circle this. I'm going to use this equivalent statement, and I'm going to right here, we can see right there that I've turned this equivalent statement into a fraction. The reason I put the miles on the bottom is because right next to it, 1.2 miles, this is really 1.2 miles over 1. So the miles is in the numerator. So once we have that situated, we can get rid of the miles. If you have a miles on the top and a miles on the bottom, you can get rid of it. Now that leaves us with kilometers. And so that's what comes into, and I can change the color here, our second part. So this is 1 kilometer equals 1,000 meters. So right here, I have put that into a conversion factor, a fraction, and I put the kilometers on the bottom because the kilometers are on the top. So we want to cancel out kilometers and get to meters. So now, since one is in the numerator, one's in the denominator, we can cancel those out. So now our next step is to multiply all of the top numerators, and we'll get 1,930.8 meters. And then obviously, if you divide that by 1, it's going to stay. So I'm going to move that up top, as you can see. So 1.2 miles is equal to 1,930.8 meters. And so we're good there. We're in meters now. Now we got to get to seconds. So we're going to be talking about time. And so I'll do this in green here. So we have to get minutes into seconds. And if we know how many seconds there are in a minute, we should know that there's 60 seconds in 1 minute. So I'll put my equivalent statement down there. I'll put my math down here. So 2.4 minutes. Again, we're taking this equivalent statement and we're going to make that into a fraction right here. And I put the minutes on the bottom because the minutes are on the top right here. So this is 2.4 minutes over 1, really. That's what it is. So if we have a minute on the top and a minute on the bottom, we can cancel those out. And that leaves us with 2.4 times 60 seconds is equal to 144 seconds, which we're going to put that back up in our givens. So now we have, and I'll do one other color here, we have meters and we have seconds. So we're all good to go because that's what it's asking for, meters per second. So now we've figured out everything. We can still use our speed equation that we learned. So speed is a distance divided by time. We're just going to plug in those numbers that we calculated and convert it into meters and seconds. And if we do the calculations, we come up with, rounded to the hundredths, 13.41 meters per second. Now, I've just arbitrarily chose to go to the hundredths. We didn't talk about significant figures or anything, so don't worry about that as of right now. We just want to get this answer into the tenths or the hundredths, so I chose the hundredths. All right, let's go to the next one. So 4, this is different. You should already notice that we're talking about velocity in this case. So velocity is different from speed because velocity is a vector, so it not only needs a magnitude, but it also needs a direction. So keep that in mind. So if we read this, calculate the velocity in meters per second. So it tells us we need to go into meters per second. All right. So calculate the velocity in meters per second of a car that travels 556 kilometers northeast in 3.4 hours. So what's given to us? Well, our displacement is 556 kilometers, and our time is 3.4 hours. Again, we have to get those into meters and seconds. So we got to make some conversion factors, but we are trying to solve for velocity here. So velocity, question mark, meters per second. All right, so let's do another box down here. And we need to understand that there's a relationship between kilometers and meters, and we already kind of figured that out. 1 kilometer is equal to 1,000 meters. So we're going to start figuring out the displacement. I wrote distance here, but I should really cancel that out. It should be displacement, so we can actually say delta x. That's a displacement. All right, so delta x, not distance. So 556 kilometers, and again, why don't we use red here? That's fine. This equivalent statement, I'm going to turn into a fraction right here. Ooh, a little out of control there, but anyway. So we have the kilometers on the bottom because these 556 kilometers is really 556 over 1. So the kilometers is in the numerator. Then I put the kilometers in the denominator there so we could cancel them out. Once we do, 556 times 1,000 meters will give us 556,000 meters, which I'll put up in our given. So kilometers, those are equal. And now we got to do time, got to get from hours to seconds. So if we understand that hours can be converted to minutes and then minutes to seconds, we're all good. So there are, if we're going to hours to minutes, there's 60 minutes in an hour. We know that, so we're going to write down what we know here. So 1 hour is equal to 60 minutes. And then minutes to seconds, the relationship is there's 60 seconds in a minute. So I'm going to write both of these down here. Then we can start to solve. So our time is 3.4 hours. Let's go orange here, that's fine. So 1 hour right here is equal to 60 minutes. My first conversion factor, I turn that equivalent statement into a fraction. I put the hour on the bottom so I can cancel out the hours on the top. Now we're in minutes. So I'm going to, let's go over to green here, it's fine. 1 minute is equal to 60 seconds. We're going to turn that into a fraction here. So I put the minutes on the bottom here so I can cancel out the minutes on the top as well. So we've canceled everything out except for seconds. That's exactly what we're looking for. So 3.4 times 60 is equal to 12,240 seconds. So I'm going to put that up there in the givens as well. So now we're in meters and seconds. We can use our displacement, or our velocity, I should say, our velocity equation. And so if we use the velocity is equal to your displacement, which is the change of x position. Really your position here is changing from 0 is your final position. I'm sorry, 556,000 meters is your final position. The initial is 0. So obviously final minus initial will still give you 556,000 meters. And so we're going to put that on there. Divide that by 12,240 seconds, and we will get 45.42 meters per second. But since it's a velocity, it also needs a direction. So I'm going to underline this northeast here because that's the direction. And that was up here in the original problem. So right there, northeast. So that's our final velocity there with a direction, magnitude and direction. And our final one is not difficult. It's just 2 problems in one. So here we go. It's asking us which object has a greater velocity. So that's the question. Which object has the greatest velocity or greater velocity here? So our 2 choices is a ball or a fish. Those are your final answers. So one of them is faster and we got to calculate that. So a ball rolling down a 3.4 meter hill in 6 seconds. All right, that's good. So we can actually write our givens over here for the ball. And our unknown, we're looking for velocity, right? So here's our displacement is 3.4 meters downhill. Okay, that's the direction. And then our time is 6 seconds. We're looking for velocity in meters per second. So let's read the fish example. A fish is swimming upstream and covering 5.4 meters in 0.4 minutes. Minutes. So that means we got to get that into seconds. So we're going to have to convert that. But other than that, we know what is given to us. We have a displacement, we have a time in minutes, and we're looking for a velocity in meters per second. Okay, so with that being said, we can solve for the ball. That's easy. Let's just go ahead and put our velocity equation in there, which is displacement divided by time. If we just put those values in there, 3.4 meters divided by 6 seconds, we come up with 0.57 meters per second down the hill. So this is a velocity, it needs a direction as well. Now going over to the fish, we can definitely use the same equation, but remember we got to change the minutes, and I'll go to blue here. We got to change minutes into seconds. So let's do that below here. So 1 minute is equal to 60 seconds. We've already found that out. So 0.4 minutes, and again, let's do it in blue here. 1 minute and 60 seconds. We took that equivalent statement. We put it into a fraction here. I put the minute on the bottom, so it cancels out on the minute on the top. So both of those can be canceled out. So 0.4 times 60 seconds will give you 24 seconds. So there you go. We have now our meters, 5.4 meter displacement, and we have our time in seconds. So we're ready to solve this. Let's put our velocity equation in there. Let's substitute our values, 5.4 meters divided by 24 seconds. And finally, we get 0.23 meters per second upstream. So those are the directions, down the hill and upstream. We've just calculated everything, but we didn't answer the question yet. So the question originally was which object has a greater velocity? And so we look at the different objects. Here, I'll do it in red here. So here is the ball, 0.57 meters per second. And then we'll look at comparing the fish at 0.23 meters per second. So obviously the greater velocity is going to be the ball. So the ball has a greater velocity. So hopefully you understand a little bit more about how to show your work. And so you can submit this into Canvas. but we've gone through all of the work. Your work should look exactly like this, whether it's written by hand and inserted into your PowerPoint for each one of these, or you want to just learn how to use that equation editor like I did to make sure that you show all your work. So thanks so much.